We will be discussing spring potential energy in this lecture. A spring exerts a restoring force, which is given by Hooke's law, F equals minus kx, where the x is the displacement of the spring from its equilibrium position. So here, let's set the equilibrium point to be here. At equilibrium point, the spring doesn't have any spring force. And if we press the spring, so the spring will have a displacement to the left. What would be the force acting on this block? It would be to the right? So this is why there is a negative sign here. It shows the spring force is in the opposite direction of the change of the spring length, the displacement of the spring. So the spring force is not constant. It increases the more you stretch or compress the spring, and the spring force is always in the opposite direction of the displacement and is proportional to the magnitude of displacement through a constant k. We call it Hooke's constant. And this equation is Hooke's law. The potential energy stored in the spring, we call it elastic potential energy. It's given by 1/2 kx squared. X is the displacement. K is the same Hooke's constant as in Hooke's law. Hooke's constant. So now the conservation of mechanical energy should be changed to including both gravitational potential energy and elastic potential energy. Should be spring potential energy. True or false? The elastic potential energy of a spring is always positive. Is it true? So spring potential energy is given by 1/2 kx squared. K is always positive. X squared is always positive. Therefore, the potential energy is always positive. Or it could be 0, right? So I would say this statement actually is not true. Elastic potential energy is always positive or 0. Positive or 0. A spring has a spring constant of 60 Newton per meter, also called Hooke's constant, so we don't get confused. How much potential energy does it store when it's stretched by 1 centimeter? So we need to convert 1 centimeter to meter. And calculate the spring potential energy. 1/2 kx squared we should have 3 times 10 to the negative 3 joules. So the answer is B.